Uh, Hello all. Am I audible? Anyone can please confirm in the chat box. Okay, thank you. Yeah, fine. So, hello all. First of all, I would like to thank you all for coming to this workshop that we are organizing. That is Advanced Process Injection V.2. And just to give you a brief about this particular topic. So we presented this specific topic last year too, and based on the requirements from various candidates, various clients we have, and this was extremely like well known. Previously it was very well loved by everyone. We had a very good kind of offering as well as presentation under this topic. So over the time we have added addition in this specific topic, and we will be presenting a lot of new techniques as well as based on the attack as well as detection on this specific part. So we will be starting the workshop very soon. Just waiting for some others to join this specific workshop, and then we will start. Might be in 4 or 5 minutes. So thank you all for joining, and we will be starting in a minute, within 3 to 4 minutes. Thank you.
Hello all, I'm audible. So let's just start the webinar. Okay, so welcome everyone. Thank you for joining us today for this workshop. My name is Nandini Bharadwaj and I'm the operating officer at CyberWarFare Labs. So as already Yash has introduced to you about this topic, today we are presenting Advanced Process Injection V.2 workshop. And just a little info before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar text box. And also, so that we have a time for the question at the end. And also, there's one good thing that also we are providing you the attendance certificate, and it will be provided within 48 hours after completion of this workshop. Okay. Okay, so let's move on to next slide. Okay, so a little info before we get started about our company, CyberWarFare Labs. So we are the EdTech cybersecurity focused platform where we provide one-stop solution for the cybersecurity problems. Also, we are working on simulating the infrastructure as a playground for cybersecurity enthusiasts. And the lower section, you can see that we are working in collaboration with IIT Kanpur and IIT Indore, India. And also we are recognized at global startup programs like Microsoft, Google, and AWS. So let's just move to other slide. Yeah, so this is our offerings. As an AdTech platform, we provide courses. This is our courses offering and trainings with practical gaming simulated labs. The taught offerings are heavily integrated in the upscaling cybersecurity skills of the candidate. So our offering ranges starts from beginner level to seasonal professional, and for trainings we look in the collaboration of information security professional, that can be any individual, government professionals, and intelligence agency and educational institute as well. Okay, so today's speaker is John Surgeon. He is a red team security researcher and he has a very good knowledge of reverse engineering, malware development, and analysis in source code review. So I guess from here, John will take over. Thank you so much.
Thank you, Nandini, for the kind of introduction about our company. Now over to you, John. Please proceed with the workshop.
Hello, am I audible?
Yeah, yes, John, you are, yes.
Okay, is my screen visible?
I think no, not as of now.
Okay, so I'm not seeing the option to share my screen.
John, can you please look at the right of the section? I think it's in there.
I think the option is not there, sir.
Just a second. Can you see it now?
Yeah, I can see now.
Okay, fine. Yeah, please proceed.
Okay, is it visible?
Yeah, now it is, yes.
Okay, thank you, sir, and thank you, Nandini. And thank you everyone for joining this webinar. Just a second. Okay, I'm John and I will be the speaker for today's webinar. So in this webinar, we are going to discuss about the process injection and some of the process injection techniques that are currently used by the threat actors and also the red teamers. So we will be doing, in this webinar, we will be doing a thorough examination of the process injection techniques that are going to cover in this webinar, and all the codes are implemented with the C. So C is required for this webinar. The knowledge in the C and C++ is required. And at the end of the webinar, you will be obtaining a material like PDF or codes that are used in this webinar. And also at the end of this webinar, you will be earning a certificate of the attendance. So let's just jump to today's context of this webinar, that is process injection. So before that, I would like to mention something about the process injection. So a few days back, I was going through some of the blogs and reading through some blogs, and one blog posted by the BlackBerry. If you look at the title here, it's the emoted returns with new method of evasion, and it's the blog was released in 2023 and it's in January, so it's the latest blog. And if you look at here, the Heaven's Gate, okay, so it's not about the Heaven's Gate, but the emoted, the malware family has used the technique known as the process hollowing. So this is one of the process injection technique, and it's a really old technique. It's like 5 or 7 years old technique, and it's still, and if you look at it, the date is 2023, and it is still being used at today's context, the process hollowing technique, and it's really old technique. And the thing is that the process hollowing technique is heavily monitored by the antiviruses and EDRs. But if we combine this technique with the other evasive technique, which specifically bypasses the EVs and EDRs, then the process injection technique will become a lot more stealthier. So we are not going to talk about any evasive technique or something like that. In this webinar, we are only going to focus in the process injection. But the thing is that it's just we are going to make sure here that the process injection technique are still used by the malwares here. Even in the present context, the process hollowing technique is used. So here are the table of contents for the webinar. So first we will discuss what are the prerequisites that are required for this webinar. Then we will start with the process injection mindset, the mindset that we need to have to perform the process injection. Then we will start with the classic process injection, and then we will go with the APC code injection. Then we will look into the section mapping technique, and we will see what are the difference between these three techniques. And at the end of this webinar, we have a new announcement to make, and that is about the mini course, which we will be discussing at the end of this webinar. So without wasting any time, let's look at the prerequisites. So for running the code that is provided here, you can have the WhatsApp box if you want to do clean operation, because doing this stuff in your own operating system will be a little bit bad. So we can so in the VMware we can install the Windows 10, and in the lab we are going to use the Windows 10. The version is 2022 S2 and it's the 64-bit. And for the IDE or editor, any editor will be used, but the Visual Studio 2020 is preferred. And we will also be using this tool, System Informer, a lot in this lab. So this is just the update version of the Process Hacker. So if you have heard about the Process Hacker, so this is the update version of the Process Hacker. So this is what we are going to use here for inspecting the processes and all. And the programming language that is required for this webinar is C or C++. If you are able to read and write, then it's really good. And here is the lab code link in here. You can download the codes that is going to be used in this lab. So without wasting any time, let's talk about the mindset that we need to have to perform the process injection. So first of all, what is process injection? It's a technique to inject a malicious code into the legitimate process so that it will conceal its presence from the system, and it will run under the context of the legitimate process. So if you look at this process here, the injector process, so this is, just assume that this is the injector process and it has some code in its memory, and we will inject this code. Let's assume that this is some malicious code. Let's just assume that this performs the reversal. So this code will be injected into the process. Let's just assume that this is the svc host.exe process, and we are just going to inject the code, the reversal code, into the memory space of the svc host.exe, and from here we are going to execute our malicious code. And in that way, what happens is whenever we see whenever we try to inspect the processes and network, then we will see that the SPC host is is connecting to some location, not the injector. So in that way, it will be a little bit stealthier. It will conceal its presence because it is running under the process context of the legitimate process. So the process injection is usually used to hide from the AV products and hide from the naked eye of the analyst. So if the reversal is from the malware process itself, then anyone can detect the suspicious process. They can inspect the process using the process monitoring tools and all, and they can easily detect. But if the code is injected into the legitimate process, it is a little bit difficult to detect this kind of code. So it will be a little bit difficult to detect the process injection techniques, the injected code in the legitimate process. And the process injection can also be used to access the resources that is owned by the another process. So let's just assume that this is the notepad process, and this is the let's say this is our injector process. So the notepad process usually perform the read and write to the file. So it reads the file from the disk, it write to the file in the disk. So if we want to perform read and write in the disk, what we can do is we can inject our code in the notepad process, because the task of the notepad is writing in a disk and reading from the disk. So from the injected code, we can hide ourselves from the within the legitimate process, and from the injected code we can read and write from the disk as well, or even we can write in the file that is currently being accessed by this notepad. And if you want to access the network, then you can find some processes which usually try to access the network. Then we can inject that code into that process, and then we can access the network from there, because most of the time the firewalls and all, they just whitelist the processes. So only a few processes can access the network in the system. So in that way, we can find the legitimate process and inject into that process to access the network as well. So this can be viewed in that way as well. And this process injection is not only used by the malware actors, it is also used in various fields, like the game hacker community. They are also using the process injection to inject the code into the game. And the security products, they are also using the process injection technique to inject their DLLs into the process space of every process that are running in the system, to hook the DLLs, to hook the APIs to hook the APIs in the process so that they can monitor the suspicious API used by the antiviruses, sorry, the malwares. And so let's talk about the mindset that we need to have to perform the process injection. So we need to have few queries before performing the process injection. So having this query will help us finding the alternative solution for the same operation. So let's say first phase of the query is that how can we access the remote process, right? There are hundreds of processes that are running in the system. And how can we access the remote process, right? So if we try to access, if we try to just write into the process, it is not possible because all the processes that are running in the user land are isolated from each other. So we will talk about this in the next slide. And another query is how can we send our malicious code to the remote process? Let's just assume that we have the access to the remote process. Now the question is how can we send our malicious code to the remote process? And there are many different ways to perform that, but the technique that we are using, the question is that the technique that we are used to send the malicious code into the remote process, is it that good or not? Because if we are just sending the buffer and we are not getting like the address space where we are just writing the buffer there, then that is not that is not good or a good way of sending the malicious code. So we will also look into this query in the next few slides. And also another query that we need to have, this is the last phase of the query. So let's say we access the remote process and we send our malicious code into the remote process, and we also know the location where the malicious code is. Now the thing is, how can we make the code execute? Because there are many different ways to perform the execution as well, and we need to find the right way to execute our malicious code, because AVs and EDRs are constantly tracking this phase of the process injection technique, the last phase of the injection technique. So we will talk about this in a detail in the next few slides. So first, let's start with the first query, that is how can we access the remote process? So in the operating system, there are hundreds of processes that are currently running. So in the user land, if you try to access to some process, it is simply not possible without getting the access to that process. We need to obtain a handle to access the process. So in Windows operating system, there is a concept called object. So most of the components are referred as the object in the Windows operating system. Like process is an object, thread is an object, file is an object. So there are more than 60 objects that are present in a Windows operating system. And these objects, if we want to access this object, if we want to do anything with the object, like not only the process but also file, thread, and any other object, we need to have the handle to that particular object, and then only we can perform further operation to that object. So likewise, for the remote process injection, we need to first open a handle to that process. And in the kernel land, we do not need the handle to access the process. We can simply have the pointer to the process or pointer to any object to access the object, but it is not possible from the user land. So that's why we need a handle with a right permission to perform the further operation. So if we look at the system informer here, so let's say this is the process here, the Chrome process, and if you look at here, there are hundreds of handle that is opened by this Chrome process. So each process maintain its own handle table. So let's say let's just open another process information, that is the from the system informer itself. So if you look at the handle table of these two processes, it's completely different. If you look at here, this has the ALPC port, the handle open to this ALPC port, but if you look at the name, it's different. So, and if you look at the handle value, it's also different here. So each process maintains its own handle table there. So if the Chrome process tries to access this object using this handle value from the remote process, it will not work because it is not mapped in this process. So that is the thing that we need to take a note into. We cannot just simply copy the handle from the remote process and make it work in the current process. So there are a few ways of obtaining a handle. One is by opening the executing process. Oh, sorry, before talking about the handle, we also need to make sure that the process, if we just go here, just take this out, and we also need to take care of that, is that let's assume that the chrome.exe is the malicious process and system informer is the target process where we want to inject our code. And if you look at the token here, the integrity of this process is medium. And if you look at here in the integrity, we have 6 integrity level here. And the process chrome.exe can only inject into the process which has the integrity same as the chrome.exe, that is the medium, or below the integrity of the chrome.exe. If the process that we are trying to inject has the integrity level higher than this chrome, that is high system or protected, then we cannot open the handle to this process because it is restricted in the user land. So that's why obtaining a handle is a little bit tricky. We cannot just simply go and open a handle to each and every process there. So here, first of all, we need to, there are a few different ways to obtain a handle. So first way is opening the process, that is the running process. So if the process is already running, using the open process API or the anti-open process API, we can simply pass the process ID into this API and it will give us back the handle value there. It will just open that process and give us the handle value to the process, and that will be mapped in the handle table of the process. So this way we can obtain a handle value, and this is usually done while performing the process injection in a live process. So if we are doing the process injection which is already running in the system, then we will use the open process API. Usually most of the time we will be using this API to get the handle to the live process. And another way of getting the handle is by creating a new process itself. So if our malware process spawn a new process, then it will have the handle to that new process. So this is usually used by the process hollowing, process doppelganging, and the injection technique which spawn a new process. And another way of obtaining a handle is by duplicating the handle value. So before we discuss that we cannot use the handle value of the remote process, yeah, we definitely cannot use the handle value of the different process, but we can we can just go and duplicate this process handle to this Chrome process. Let's say the Chrome process is the malicious process, then we can simply duplicate the handle value from this process into the handle table of this Chrome process. In that way, we can have the handle to this svc host.exe process, and then we can perform further injection into this svc host.exe. But to copy the handle, we need to open the handle to this process itself. But sometimes what happen is like the antiviruses will scan the open process and open process APIs, and if the process is opened by the it will track whether the process is opened by the chrome.exe or not. Since we are not opening the process, we are simply duplicating the process and doing the injection in this svc host.exe, then it is not considered as the opening of the process. It is just, we are just duplicating the handle value here. So that way it can evade some of the antiviruses as well. Now another query is, how can we send the malicious code in a remote process? So there are many ways to send a malicious code to the remote process, but before sending the malicious code to the remote process, we need to have the few queries in our mind. So the first query is, do we have the enough privilege to write code into the remote process? That is, it is referring to the handle value here. So let's just go to the handle table as well. And if you look at the handle value here, so this process chrome.exe, let's just assume that the chrome.exe is a malicious process. And it has open, let's say this is not ALPC port, let's just assume this is the process object. And if this process has opened the handle to this, let's say some process, XYZ process, and it has the full access to this process. So this granted access is mapped to the handle value here. So this handle value, if you are given the handle value back, so you have the some granted access attached to this handle value as well. So the handle value that you have has the full access to this object. If you do not have the if you do not have the write or read permission there, so sometimes you can just have the query and traverse permission, and sometimes you do not have the write permission there. Sometimes you do not have the read permission to the process. So if you do not have, if the handle that you have obtained do not have the read and write permission, then you cannot perform read and write operation in that process. So this is the thing that we need to note here. And to be able to write in another process memory space, the handle value should have at least this flag, which is process VM write, which is a writable permission. So, and another is process VM operation. So here is a small typo here. It's a process PROCESS. So the handle needs to be at least this permission to be able to write in a remote process. And another query that we need to have is, can we locate the address of the malicious code in the remote process that we just sent? So let's say we send, with some technique, we send the malicious code into the remote process. But can we know the location of the payload where it is sent to? Because we need a location of the payload to be able to perform further operation in that process. Because just by sending the malicious code into the address space of the remote process is not going to execute the payload itself. So we need to have the address of the location of the payload so that we can perform further operations like execution of the payload and all. So this is the thing that we need to take care of. And another query is the memory region where we are trying to send our payload, whether it has the access write and executable. So if the memory page in which we are going to send our buffer has the write access, then we can write into that memory page. Even let's say if we have the write permission obtained in a handle to this process, but we have the page which do not have the write permission, then we cannot write into that page. Okay, so let's just look at here. In the memory region, you can see there is the page here, and the page has the read and write protection here. And if we look at here, all the page has read and write and read protection here. If you look at here, if you try to inject the code into this page, you will not be able to inject because it does not have the write access here. You cannot write into this space because the protection of this space is just the read. You can only read from this space. You cannot write into this space. So we need to take care of this thing as well, because to be able to write into this process, we need to have the page with the read and writable permission. And the interesting thing is that most of the time, so when we write the payload into this memory region, let's say we write the payload into this memory region, to be able to execute the payload from this memory region, the page needs to be executable as well. But if you look at here, it's the read and write only. We cannot execute the code from here. So we also need to take care of this information as well. And normally, if you look at this process, you will not find the page with the read, write, and executable, or even write and executable, because the page could be either writable or executable. It cannot be both. But some of the processes could can create a page with the read, write, and executable, so we can hunt for those pages as well. But normally, the page will not have the write and executable at the same time. So that's why normally we write a payload in the read and write page protection, and then we will change the page protection to read and executable. So we will talk about this later. So normally we send the payload using this technique. That is, first we will allocate the new memory region in the remote process. So to allocate the memory region in a remote process, we will be using virtual alloc EX API, and the anti version of this API is anti-allocate virtual memory. So normally with this API, we can create any page protection page. That is, we can create a page with page, read, write, and execute with all three permission enabled there. But this will be a little bit suspicious. Creating a page with read, write, and read, write, and execute permission, and writing into that page and executing from that page is quite suspicious. And any process monitoring tools or process memory scanning tool can detect the memory page. They can heavily scan those pages. So first, in this technique, what we do is we will allocate the memory page with the page read write protection, and then we will perform the write in that page using the write process memory. So using the write process memory, we are going to transfer the code from our process to another process. And the interesting thing about the virtual alloc EX is that it is going to give us back the address where the new memory location is allocated in the remote process. So we will be having the address of the newly allocated memory region in the remote process. So, and we are going to place our shellcode in that memory region, and we know the location of the payload, so we can do further operation in that address. If we do not know the payload address, and let's say we somehow manage to transfer our buffer in there, then we do not know where to find the payload. It's because to perform any further operation, we need to have the location of the payload. So that's why having the location of the payload, if you find something new technique to allocate the memory, and that also returns the payload address, then that will be really great. But normally we use the virtual alloc to allocate the memory region in a new process, and then we use write process memory to write into the memory region of the remote process. And so at this point, we allocated the memory page with the page read write protection. Then using the write process memory, we write our payload buffer into this memory page. Now the page is not executable. If we try to execute the code from the page which has read and write, then it is not going to work. So in that case, we can change the memory protection. To change the memory protection from read and write to page execute and read or anything other than this one, we can use the virtual protect EX API. And the anti version of this API is anti-protect virtual memory. So using this API, we can change the memory protection from read and write to read and executable. And then we can perform the execution from there. Now this is the final query that we need to have in our mind, is that how can we execute the malicious code. So up until here let's assume that we have found the process, and we have allocated the memory in the new process, that remote process, and then we send our buffer into that remote process, and we also know the location of the payload. So now what we are going to do is we are going to execute our payload, and also we have changed the memory protection from page read write to executable. And up until here, let's say everything is good, everything is fine, and here we have some common way to execute the code now. So first way we can execute the code is we can create a new thread using the create remote thread API. We only need to pass the address of the payload to this API and some other settings there in the parameter, and then it is going to create a new thread, and the thread will start from the base address of the payload that we pass to this API. And the alternative version of this API is the anti-create thread EX, and we can even use RTL create user thread. So this is in this technique we will be creating a new thread, which is a little bit suspicious because creating a thread in a remote process is quite suspicious. And another technique of executing the code is using the APC queue. So using the queue user APC, we can queue the APC in a remote thread. So in this technique, we are not going to create a new thread. We are going to use an existing thread in a remote process. So remote thread might have some thread there. So we will target a thread and we will queue our APC. We will queue our APC. That is the for us the APC queue that we are going to inject is our cell code, the address of the cell code. So we will be queuing our APC in the thread and the thread in the remote process. So that means the thread which the already existing thread in a remote process is going to execute the code. So here we are not creating any remote thread here. We are just queuing the APC in the remote thread, and the thread itself is going to execute the code. But here is some limitation. The limitation is that the thread needs to be in a alertable state, and only after that the code can be executed. So we will talk about this in a few minutes while we are doing lab. So just understand that in this technique we are not going to create any thread. We are just going to queue our APC in an existing thread which is running in a remote process itself. So we are making the remote process thread to execute the code itself. And we also need to take care of few things which we are going to discuss in a lab section. And another way of executing the thread is hijacking the thread context. So each thread running in a process has its own registers. So in this case, we are going to obtain our thread registers. We are going to hijack the thread registers, this thread context, and then we are going to modify the registers in a way that whenever the thread is resumed, it will execute our code. So these are the three common ways of performing the execution. And this is the last phase of this process injection, so that the last phase of the injection, it is heavily monitored by the AVs or any security products. So if you just perform up to here, and if you do not execute any thread or if you do not perform any execution, then it will not mark as the malicious. But as soon as you execute the code, then it can generate the serious alert. But up to here, the events will be generated like you have performed something suspicious, but it could not be even generated. But if you create a new thread, then or if you execute the code there, or if you perform any execution after this, then it will be like heavily analyzed and it will retract and the alerts will be generated. So this we need to be little careful in this part of the phase of the process injection. So here are the common APIs that are used in this process injection technique, that are used in crafting the process injection techniques. So for querying the process and thread, we can use the create tool help32 snapshot to query the process and thread. We can also use anti-query system informations to query the process and thread. And to query each process, then we can use the anti-query information. To query the thread, we can use the anti-query thread information. And to open the handle to the process, we can use the anti-open process. To open the handle to the thread, we can use the anti-open thread, and we can also use the Win32 API version of this API. And we can use the GW duplicate object to get a handle to that particular object, or we can simply use the duplicate handle API to duplicate the handle. And to read from the remote process, we can use read process memory, or the anti version of this API is anti-read virtual memory. You can even use this API to read from the remote process. And to write into the remote process, we can use write process memory, anti-write virtual memory, and the GW map view of section. So this one is a little bit interesting to see, which we are going to look in a lab part as well. And to execute a code, we have few different options here. That is, we can create a thread using the RTL create user thread, or create remote thread, or anti-create thread EX, or else we can queue the APC core using the queue user APC, anti-queue user APC, and we can even hijack the thread using the set thread context. So these are the common APIs, and we have discussed about the mindset that are required for the process injection as well. So we will be taking few minutes break, like 2-minute break, and then we will start with the process injection technique. So until then, if you have any queries, then you can ask.
Hi, John.
Sir?
John.
Yeah, yes, sir. Am I audible?
Yeah, you are audible. Yes. You can, start. I will see, what I can do in this.
Okay. Now I will continue from here. Okay, so now we will start with the first injection technique, which is a classic process injection technique. So this is simply oldest technique in which we are going to inject our code in a live process. So to perform this classic process injection technique, first we are going to obtain a handle, and we will be opening the process using the open process. We can even query the processes. If we have any target process, we can query the processes, and we can find the target process using the create to health 32 snapshot. And alternatively, you can also use anti-query system information. And once we get the process ID, we can open the process with the open process API, or we can simply pass the process ID to this open process. We can hard-codedly pass for the lab purpose, but in the real world, we need to find the target process and thread, the process ID dynamically. But here in the lab, we are just going to pass the process ID in the open process. And after that, after opening the handle to this process, we are going to allocate a new memory at the target process using the virtual alloc EX or anti-allocate virtual memory. And after that, we are going to write our payload into the newly allocated memory using the write process memory and anti-write virtual memory. And here we need to take care of the page protection, which we are going to see in the lab itself. And using the create new remote thread, using the create remote thread, we are going to create a thread so that whatever payload we have written to the memory region, and after changing the memory protection from read write to read executable, we are going to create a new thread which will execute our code. So this is how we can visualize this. So we have the malware process, just the injector, and this is our shell code. Now we will inject this shell code in here. So here is the thread which is already running. So this is the legitimate thread. We are not doing anything here with this thread. Now we will allocate the memory. Then we will inject the code into the memory region of the legitimate process. Then we will create a new thread which will execute this code. So this is what we are going to do in the classic process injection. And these are all the APIs that can be used in the classic process injection. Now let's move to the lab, and let's see how it can be achieved. So let's just open the system informer as well. So we are going to inspecting everything that is happening in here. And let's just open the target process. So our target process will be Notepad. In real world, we will not be targeting the process like Notepad. We will be finding a legitimate process, but for the lab, we are going to use the Notepad. So it's a very nice process to test our process injection technique. So now let's find the process. And if you look at here, the process ID is 628. Let's just go to the set this as the startup project, and in here we can go to the properties, and inside the properties there is the debugging section, and these accept the parameter. So we just need to pass the process ID here, that is 628. We are passing the command argument here because this program accepts the parameter. If you look at here, we are getting the parameter from here, and then the parameter that we are retrieving is the process ID. So that's why we were passing the process ID here. And this is the cell code. The cell code is the hello world cell code, and we are going to inject that in a remote process. So here we are passing the process ID, the payload size, and the payload itself. So here we are using the anti-APIs, and we are initializing all the APIs here. So using the get process address, we are getting the address of the function from the anti-DLL module, which is loaded in the memory. And we are just getting the function address of the other anti-functions as well. After getting all the addresses, we are going to open the process using the, now we will be calling the the functions that we just retrieved the address of, and the first of all we will be calling the anti-open process. And if you look at here, we use the get process address to obtain a address of the anti-open process in a memory as well. So we have so we will be having the address of the anti-open process. So let's just put a breakpoint here, and let's not worry about the initialization. These are just retrieving the addresses, and that's it, an initialization of a few variables. So let's just execute this program here. And if you look at here, we hit the breakpoint, and here we are passing the process ID in the CLID unique process. And here we are passing the process ID, that is 274 in hexadecimal. So we can just simply add this in a watts, and we can simply convert this from hexadecimal to the normal value, that is 628, and we can confirm this in a process here, system informer here, the process ID is 628. So let's just get a hexadecimal view, and here we will be receiving a handle to this particular process. Currently it's 0xFFF, so it's an invalid handle value. And once we execute this API, we will be getting a handle value. And if you look at here, the handle value is A0. So let's just go to the system informer, and the process is the classic process injection. And inside the handle table here, if you look at the process here, is the notepad.exe, and it has the full control over this handle. The handle value we granted has the full control over this particular object, that is the notepad.exe. And if you even look at the process ID, it's the 628. And this is the same handle value here, A0, and it's the A0. We can confirm this now. And using the anti-allocate version memory, we are going to allocate a new memory region in the remote process. So anti-allocate version memory, then we are passing the handle to the remote process, that is the notepad.exe. Then here we are going to receive a remote base address. So the location of the payload is really important here. And we are committing, we are just the base type is just mem commit and mem reserve, and this one is important. We are allocating a memory region with the page read and write permission, sorry, the write access. So let's just enter this, and if you look at the remote page, let's just dump this in our watch, and this is the remote page. Now we can go to the system informer, and we have allocated the memory in the notepad, and the memory region is the 1D60B08. So this is the memory region that we just allocated, and if you look at here, it's empty here. So it's just the empty page that we just allocated, and the memory protection is RW, read and write. Now we will simply write the buffer into that memory region. So we will be using anti-write version memory, and then here is the handle to this process. So in this process, we want to write the payload, and in this process and in this base, we are going to write the payload buffer, and the size of the payload buffer is 1B2. So let's just execute this API. Then we can go to the system informer and just reread this. If we just hit on the reread, it will going to refresh this memory page. And if you look at here, we have the payload here, and you can see it's the hello world message as well. So we are just injecting the message box cell code. Now we have written the payload into the memory region. All we need to do is change the page protection now from read and write to read and executable, because if we try to create a thread in the page which is read and write, then it is not going to work, because the page is not executable. It is simply going to get crashed. And using the using the anti-protect version memory, we are going to change the memory protection. If you look at here, this is the handle of the remote process, and this is the base. So this is the same base. So we are going to change the memory protection here. So we need to pass the page address as well, and this is the size of the page which we want to change the protection. And if you look at here, this is the flag which we are setting in here, that is the page execute read. That is from read and write to we are changing to read and executable. So this is the flag for the read and executable, and it has the constant value as well. And this will be saving the old protection, that is the old protection will be read and write. So let's just execute this API, and let's just go to the here and just refresh. It's currently read and write. The page is 1D60B0800. If we just refresh and reload this and look at here, the page is read and execute. Now the page is executable. All we need to do is create a thread. So if you look at here, there is already a main thread running here, that is 14708, and this is the stack of the particular thread. And now let's just create a new thread here. If we just call the anti-create thread ex, we will be getting a new thread. Here we will be retrieving the handle to that new thread. Then we are trying to get access to get all access to the particular thread that we just are creating. And this is the process in which we want to create a thread, and this is the handle to the remote process, and this is the base from where we want to execute our code, that is 1D60B0800. So this is the same base that we just make the executable. And here we are not creating if we want to create a thread in a suspended mode, we can also do that. So to do that, we just need to set this value true. But we are not creating the suspended thread, so we are just going to create a thread. And currently, if you hover over here, only the notepad UI is there. Now let's just hit the continue button, and if you look at here, the cell code is now popped up. So we have executed our cell code from the notepad process. And even if you look at here, the new thread is created, is the 1496. And here you can see it is starting from this address 1D60B0800, if you look at it, only the offset is 81. From offset 81, it called the kernel32.dll, and it called, and from here, this address 80050 offset, it called the message box, and it's all it is. So it just executed our code here. The shell code is executed now.
John?
Yes, sir.
Yeah, sorry to disturb you. Can you please open the control panel? The questions are present under the questions tab, not in the chat box.
Okay, so I have this panel here, and
Actually, I cannot see this, but under the questions tab, it is available.
oh, okay, yeah.
You saw it?
Yeah, these are the questions now.
Okay,
Okay.
cool. Okay, take your time. Okay, thanks.
So should I start with the new technique, another one?
Yeah, you can clear the questions first, and then you can start.
Okay, so the question is, okay, so let's start with the answering the question of the JSON. So the difference between the native API and Win API is that native API. So firstly, the native API, it's all from the anti-DLL. It's a low-level DLL, and other APIs, Win32 API will be, it's a subsystem DLLs like kernel32.dll or advapi32.dll, and these are just the wrapper function, right? The API is, let's say, the create process API, and there is the anti-create process API. So anti-create process API is the last API that is going to be called before performing the transition. So everything, so when you call the, let's say when you call the anti-create process EX API, all the setup will be going in a kernel level. So that is the last API that is going to be hit in a user land. And in the anti API, you will be seeing the syscall stub there. You will not be seeing the code there. Actually, you will be seeing the syscall stub, and those syscall is going to call the API there. And those system syscall will be going to perform the ring transition, and it will find the anti-create process EX in the kernel land, and everything will perform from there. But while you call the create process API, the create process API, you will pass some parameter, and it's just a wrapper function. It will just manage every parameters that are required for the low level API. So for the create process API, the low level API is the anti version of the API is anti create user process. So the create process API is going to process the parameters, and it will check the parameters that are coming there, and then after that, when it checks every parameters, it will pass the parameters to the anti version of the API. So Win API is just the wrapper function to the anti version of the API. So it just process the parameters. Then after processing the parameter, it will going to pass the parameters to the anti version of this API. So create process will be process the parameters for the anti create user process API, and then anti create user process API is going to call the system call, and there will be the ring transition from user LAN to kernel LAN, and from the kernel LAN, it is the anti create, the real code begins from there. So Win API is just the wrapper to the native API. We can say that. Yeah, Process Hacker, yeah, it works on Windows 11 as well. So another question from the Nazar Amin. Okay, so if the so we cannot, if we, let's say the Chrome process. So the question from the Nazar Amin is that in example it showed Chrome and SVC host. Chrome was a lower privilege and SVC host was the higher. Are we still able to duplicate and use that handle? Okay, so to duplicate the handle, we first need to open, let's say the Chrome is the malware process, and SPC, his host, is the target process, and SPC host has the higher privilege. First of all, we are not going to opening the handle to the SPC host, because if we open the SPC host from the and because to duplicate the handle opened by the SPC host, we first need to open a handle to the SPC host itself. And if the SPC host is the higher level privilege, we cannot open the process from the Chrome, that is the lower level privilege. So but what we can do is, there is a small, if there is small misconfiguration, let's say SPC host is the target process in which we want to open a handle to. Let's say we want to duplicate the handle of the SPC host, and the SPC host has the higher level privilege. But SPC host is, let's say, opened by the another process, let's say MS Edge. MS Edge has opened to the handle to the SPC host. So and the SPC host has the higher level privilege, and MS Edge has the same level privilege as the Chrome. Then Chrome can open the handle to the MS Edge, and after opening the handle to the MS Edge, it can duplicate the handle opened by the MS Edge, that is the SPC host, and SPC host has the higher level privilege. Then in that way we can duplicate the SPC host privilege. But normally, if the SPC host has the higher level privilege, we cannot even open that process, because the privilege is high, and to do anything with the process, we need to first open the handle to that process. And the scenario that I just mentioned is that when we there is a services that once the higher level services want to perform some tasks in the lower privilege level. So in that case, what they can do is they can spawn a child process, and sometimes because of the misconfiguration, what happen is they will allow the child process to open the handle, to inherit the handles that are opened by those higher level privileges. So in that case, if the higher level privilege, which just spawned the child process, has opened the handle to itself or to other privileged process, then those handle will also be leaked to the child processes, which has the lower child processes with the lower level privilege. So in that case, what we can do is our chrome.exe, assume that it's a malicious process. So we can open the handle to that lower level privileges, and just assuming that the lower privilege has inherit the handles to all the privilege process that is opened by its parent process, then we can just find that privilege processes and we can duplicate the handle to escalate the privilege. So this is also possible in this scenario. But if we just try to open a handle to the higher level process, it's not going to work. And another question is also, yeah, it's from the NASA. I think he's clear now. And another question is from Snacky Hack. It's does Sysmon to create any events, or in event viewer security events we can see the remote thread creation? Yeah, so the Sysmon, when we install the Sysmon, we can have the rule set, and for the remote thread creation, I think we can also set that rule in the Sysmon, and that will be visible in the event view as well. For the security events, like if the events is from the Windows Defender, if Windows Defender has detected let's say Windows Defender has detected the process following, in that case, the creation of the thread might be locked. But if that particular process injection technique is not detected by the Windows Defender, then in the security events, it might not be locked as well. Okay, now we can start with the APC code injection. So this is really interesting technique used by the malware actors. So APC is not a malicious in itself. It's a Windows mechanism, also used as the software. It's also known as the software interrupt and all. So this is just the mechanism of the Windows operating system. It is not a malicious component. It's just a normal component which is used by the Windows operating system. But malware authors, threat actors, they use this APC to perform the code injection. So the APC function is going to queue the APC in a particular thread, and the APC will be our payload. So that payload will be executed asynchronously in the context of that particular thread. So let's just assume that we have the process A and process B, and process B has some thread running, and process A is queuing the APC in the remote thread. So the thread that is going to execute where we queue the APC, that will execute the APC code, and that APC code will be our malicious payload. And the payload will be running under the context of the process B. Now we queued the APC from the process A to process B, but when the code is executed, when the shell code is executed, the shell code will be running under the process context of the process B, thread context of the process B. That means it is running under the context of the process B as well. So if we so there are two things to be noted while performing this execution. That is, first thing is the APC, the thread needs to be in a alertable state, and another is the parameters and everything that is required by the shell code needs to be in an address space of the process B. If we are queuing in a process B threads, then the shell code, when it executes, it needs parameters that it required to be in a process B itself. So if the parameter is in a calling process that is in a process A, then it will not going to work, because the code will be run under the context of this process B. And so the thread needs to be in alertable means that, let's say the thread can be put in a sleep using the sleep API, but using the sleep EX API, we can make a thread sleep, but it will be in an alertable state. That means whenever we queue the APC, whenever we queue the APC, it will be awakened. Even the thread is sleep for the infinite time. So if we pass the sleep EX and the time the period of time that it want to sleep to the infinite, and then if we just put the alertable status to true, then the thread will be put in a sleep for infinite period of time. But whenever we queue the APC, it will be awakened. That means the thread will be start executing again, so something like that. And so in that way, if the thread is in an alertable state, once we queue the APC, it will start executing our code. And another scenario can be the thread might not be in an alertable state. Let's say we can even queue the APC in the thread which is not in an alertable state. And once the thread enters into the alertable state after queuing the thread, it will also going to execute our APC code. So we can have these two scenarios. So this is not reliable. If we just inject into the random thread, it is not reliable because we do not know the thread, whether the thread will enter into the alertable state or not. So we need to take a note into that as well. So here are the few steps to perform the APC code injection. So first of all, we need to find the process, the target process where we need to inject our payload. And we can do this by using Crate tool Health 32 snapshot or anti-query system information. So under the hood, so under this API, the Crate tool Health 32 snapshot, the anti-query is being called. So this is the let's say this is just the wrapper function to this anti-query information. We can call this as the win API, and we can call this as the anti API. So this API is going to call this API. So instead of this API, if we want a little bit stealthier, then we can use the anti version of the API as well. And after that, we are going to find the thread in the target process. So we will be using thread 32 first and thread 32 next to query all the threads, to find all the threads in that target process. And after that, we will be allocating the memory in the process. So this is the interesting part, because if we are going to queue our APC in a context of the another process, another thread, then we need to have our shell code in the another process as well. So that's why we need to copy our code into that process, into the target process. So that's why we will be allocating a memory in the target process. Then we are going to write the payload using the write process memory into that target process. And we also need to take care of the page protection as well, because we will not be allocating read, write, and executable memory page. And after that, once we handle the page protection as well, after writing the payload, we will simply queue the APC in all the threads there in the process. So whatever threads we have retrieved from this process, we are going to queue our APC in all the threads. And whenever one of the threads enters the allotable state, if the thread is already in allotable state, then our shell code will going to get executed. That's why this is a little bit not a stable technique, because the thread might not even go in a allotable state during their entire life cycle. And this is not stable. So we have another alternative for this technique, which is quite stable, which is really stable than this technique. So we will also be looking into that technique. That is called early bird injection technique. So let's just visualize this APC code injection. So let's just assume that we have the thread, and the thread is in an allotable state. That means this thread is awakeable, even it's sleeping for the infinite period of time. So we have the payload here, and we have the thread, which is already running there. And then we will queue our APC function in this thread. So as soon as we queue our APC in this thread, it will start executing our code. So this is asynchronous, like it will happen at the random period of time, but as soon as we queue the APC, it will definitely going to get executed. So there's a small let's just a little bit internal of this technique. So what happened is, like when we queue the APC and sleep EX is entered, so whenever from the ring transition, so from it will enter the kernel level, and when the code return from the kernel level to the user level, let's say it's just exiting from the system service, at that period of time, it will check whether there is the APC queue in this particular thread. So we have queued the APC, and when returning from the kernel LAN to the user LAN, it will check whether there is the APC queue in there. If there is the APC queue, and if there are user APC that are pending, then it will try to go and figure out the APCs, and it will deliver the APC. But if there is no APC queue at the time, then the sleep thread EX will not be awakened, because it is sleeping for the infinite period of time. And if we have not queued any APC there, then the thread will not be awakened. So if once we queue the APC, and whenever the system exit is triggered, like whenever the kernel transition is happening from kernel to user LAN, the APC queue in there will be checked whether there is the user APC in a queue. If there is a user APC in a queue, then it is going to deliver our APC code. So these are the APIs that are used in the APC code injection. And so some of the APIs are Create Tool Health32 Snapshot, Process 32 first, Process 32 next, and other APIs we are already familiar with them. And we can also use the anti version of the API. So now let's jump to the lab part, and then we will see how this APC injection work, how we can implement the APC injection. So let's just go to the APC injection code and open this code. So we have two techniques here. First is the normal one, and other one is the early bird. So this is the normal one is little bit unstable. So it is not guaranteed that it is going to execute the code. So it might even crash the process as well. So let's just open the target process first, Notepad, and in the normal, we set the mode to the normal for now. And this is the shell code that we are going to execute, that is hello world. And in the APC injection function, it will check whether it's the early bird technique or not. If it is not, then it will start from here. If it is early bird, then it will enter in the early bird code. But here we are just doing the normal injection, APC injection for now. So we will start from here. So the target process where we want to inject our APC, the thread of the process is the Notepad process. So this is our target process. And inside this API, we are going to find the target process. So let's just put a breakpoint here and just execute the program. And we have the vector here. This is going to collect all the threads that are present in this particular process. So let's just step into this function, find target process function. This is just the wrapper function. And inside here, we are calling the create tool health 33 snapshot. So here we are just initializing these variables. And after that, we will call the create tool health 32 snapshot, and we are taking the snapshot of the process as well as the thread. And we have the handle to the snapshot. And using the process 32 first, we are going to get the first process information using this process 32 first. So if we just execute here, and if we just hover over here and look at here, is the system process. And the process ID for the system process is 0. And here it will check whether the executable name, that is system process, is equal to our target process, which is the notepad.exe. So let's just step over this function, sorry, the code. And if you look at here, it did not match here. So we are in this code. And if the process name did not match, then we will go and look for the next process in the snapshot. And once we call the process 32 next, the P32, this variable will get updated. Currently it's the system process. Now it will be the system process, only the system. And if you look at here, it's the system, and it is getting checked whether it is equal to the notepad.exe. It's not. So we will be doing until it finds the notepad.exe process. If you look at here, it's the registry. So if it finds the notepad process, then it will enter the line number 24. So let's just click on the continue. And now it founds the process, that is the notepad.exe, and it is mapped. So it's now it has entered this code. Now we will be getting the process ID, that is the process ID for the notepad is 3C38. So let's just dump this in a watch. Sorry, let's just step over this code and just dump the PID. The process ID that we retrieve is the 15416. So let's just go to the system informer and look at the PID is the 15416. So we have found our target process here. And we will be doing the same thing for the thread, for finding the thread. And we are using the thread 32 first to get the first thread. So we are not getting the thread from the process. Actually, we are getting the thread from all threads that are running in the system, all the threads that are running in the system. So first we need to get the first thread, and here we will be getting the thread information. And after that, in the loop, we will check whether the owner process ID of the thread is equal to the target process ID. So if the owner process ID of the thread is equal to the target process ID, then that thread belongs to the notepad.exe, because our target process is the notepad. But if it does not belong to the target process ID, if you look at here, the owner process ID is 0. So this is for the system process. And if you look at here, the process ID is the 1541. That means this thread this thread is not for this thread does not belong to the target process. So it will go and look for the another thread using the thread 32 next. It is going to get the next thread in a list, and if we just go execute this API, it will have another information, and if you can see, still the owner process ID is 0. So let's just put a breakpoint, and because because the thread lists are really huge, so we just put a breakpoint here, and whenever it matches, it will just hit the breakpoint here. So we have hit the breakpoint here, and if you look at the owner ID of the thread is the 15416, and it is matched with the target process 15416. Now in the vector, we are going to push the thread ID, that is 13368. So if we look at the notepad here, so one thing to note is that we have taken the snapshot that is 1 minute back. So 1 minute back, there could be 2 or 3 threads or only one thread. But at this point, there could be many other threads as well. So the thread ID that we are going to save is the 13368. So it's here. So while doing this thread might also be terminated. So that's why. So this is just the history. Now the live thread are still going on running here. So those thread might be like terminated as well, or there could be new thread added there as well. So you can see other thread is also matched here. So let's just continue this, and we will go and put the breakpoint here in this line of code, which is 126. So let's just put the continue, and okay, so now okay, actually I accidentally clicked on the I accidentally double clicked on here. So what we do is we will simply run this program again, and then we know what is going on here. So let's just remove the breakpoint. So we are collecting the thread IDs of the target process in this vector, and we are also getting the process ID of the target process, that is the notepad. So we are here. So let's just step over this function. So we will be right now the process ID is 0, the target process ID is 0, and the thread ID you can see it's empty here. So if we execute this function, we will get the process ID, the target process ID, and we will get the thread. Now you can see the currently it's only one thread there. So previously it was 3 thread running there. Now if you look at here, it's only one thread running here, which is the 13368. And we were just querying the process. We were not opening the handle to that process. So we need to open the handle to this process to be able to perform operations like allocating the memory and writing the cell code into that memory. We need to have the enough access right in the handle. So using the open process, we are going to open the process, and we are asking for full access to that process. And we have passed the process ID of the notepad 15416. Now if you look at here, we have the handle to this target process, which is A4, and we can just go and confirm this here. The handle value was the A4. You can see it's the notepad, and now we have opened the handle. All we need to do is allocate the memory in the remote process so that we can queue our APC. And currently, if you look at here, the base address, it's empty here, and the target process is the notepad process handle. And let's just go, and so the page we are allocating is read and write only. And if you look at here, we have the base address 260.219.0. So let's just add this in a watch, and in the notepad we allocated the memory. So let's just find this address 26021, 260219200. So this is the memory page that we just allocated, and if you look at here, it's the read and write, and currently it's empty. So using the write process memory, we are going to write the payload buffer in this address. So let's just go and execute this write process memory API. And if we just go to the process hacker and reread this, you can see we can see the load library and message box say hello world. So this is our shell code that is written in this memory region. And if you look at this page here, the page protection is read and write only. Now using this WhatsApp protect EX, we are going to change the protection. So let's just refresh this. It's the same thing. If you look at here, the address 2602192. So this is the one, and if you look at here, the page is executable now. It's ready to execute the code. So all we have to do is to execute the thread, and to execute the thread, we are going to loop through the threads in the vector, the thread IDs in the vector, but currently we only have the one thread there. So here we will be opening the thread using the thread ID, and open thread is used to open the thread, and here we will be getting the handle to that particular thread. Then using the queue user APC, we are going to queue the APC routine. So if you look at here, the base address 2602192. So we have given the base address of the cell code to the APC routine, and we are going to queue our APC in this thread, which is this thread that is 1313368 from the remote process. So we are going to queue our APC, and let's just continue this one, and it will sleep for 2 seconds, and it will go back and check whether there is another thread in the list as well or not. If there is not, then it is just going to exit from this loop. But if you look at here, our cell code is not executed because the thread did not enter into the alertable state, and the thread is still not in a alertable state. It is still running there. So that's why it is quite unstable. So we have the other option here, that is the early bird injection. So we are not going to look into the allocation and all for this technique. So just we are going to change this technique to the early bird. And let's just exit this process, the notepad process. And once we change this mode to the early bird, we will go and put the breakpoint here because we are going to enter into this early bird code. So let's just put the breakpoint here and execute this program. Actually, the process is still open here, so we need to sort that process. So now you can see we hit the breakpoint in the early bird. Now we enter this code. Let's just step into this function, and in here the target function is the target process is the notepad.exe. So this is the target process, and what we are going to do is we are going to create a process in a suspended state. So if you look at here, the create process, we are creating the process in a suspended state, and this is the target process, which is notepad.exe. And if we go in a system informer, and if you look at the notepad, it's no other instance are present there. So if we just step over this function and look at this process here, it's the gray, the highlight is gray. That means the process is suspended state, and the process ID is 8888. And if you look at the thread, we only have one thread, and which is in a suspended state. So once we resume the thread, it will check whether there is any APC pending. If it is, then it will clear all the APC and it will start execute. It will initialize the thread and it will clear all the APCs and it will start executing the thread. So that's why even if the thread is not in an alertable state, this will work for the early bird injection, because there are some APC queues already there, and in the thread. While creating a thread in a suspended state, there will be already some APCs. If there is not, we just going to queue the APC there, and after that the thread will start and it will clear all the APCs that are pending in there, and it will start executing. Currently, if you look at here, the thread is in a suspended state, and we know what this function does. So it is just going to allocate the memory in that process, in the notepad process, and this is the memory region where it is allocated 2200E97000. And using the write process memory, we write the payload buffer into that address. So we already know what it is going, and we need to change the memory protection from read and write to read and executable. We will be using virtual protect to do that in this base address. And this is the process, that is B0, which is the newly created process, which is in a suspended state. And after that, we can queue the APC into that process. So we don't need to find the thread. Once we create the process, we will have the process information, and here we will have the handle to the process and handle to the thread itself. So that's why we do not need to open the handle to the thread like we did in the APC injection. And once we queue the APC in the thread, the APC will be queued in this suspended process thread, that is this thread. And if you look at here, there is no message box right now. And once we resume this thread, the message box will be appeared. So instead of the notepad UI, we will be seeing our shellcode there. So let's just resume the thread. And if you look at here, we have the notepad, and notepad is popping up the message box shellcode. So this is the shellcode that we queued in the APC of this thread. And if we just go to this notepad thread, and if you look at here, this is the thread. So this is the main thread that let's just go and confirm this. The thread ID, that is the 15684. This is the thread ID in which we queued the APC 15684. And this is the 15684. And if you look at the stack of the 15684, you can see this is the address where it invoked the message box A. So if you look at the stack, if you look at here, the addresses, we can see the clear addresses of the payload here. So this could be malicious as well, because normally if you look at the stack here, the stacks are backed by the legitimate DLL like user32.dll, win32u.dll. But if you look at here, this is the address itself. So if you find this kind of addresses, then this is quite malicious, because most of the time, if you look in the thread, you will only see the you will see the APIs that are backed by the legitimate DLL. But here you are seeing, if you see here, we are seeing the address of the shellcode. So this is how APC injection work. And now let's move into the another technique. So now we will discuss the last technique, that is the section mapping. So this is quite really interesting technique. In the previous technique, we used the anti-virtual alloc memory and our virtual alloc EX API, and we use the write virtual memory or anti-write virtual memory or write process memory to write into the process memory, and then we use the anti-protect virtual memory or virtual protect API to change the protection of the memory. But in this technique, we are not going to use all of those API. So how are we going to send the malicious code if we do not use that API, right? Because in the two technique, we use those APIs to allocate the memory in the remote process, to send our payload buffer in the remote process, to change the memory protection of the remote process in the page of the remote process. But here we are not going to use all of those three API. So how are we going to send our malicious buffer there? So let's talk about this section first. So section is an object that is just a piece of memory that can be shared between multiple processes. So here, if you create a section, then this section can be shared between multiple processes. That means process A and process B. That section can be shared between these two processes. And so the process, they do not view the section, but they view the what called views of that particular section. So we will see this in an image later. So each section has the corresponding view. That means the one that is visible to this process is not the section, but the view of that section. Let's say, and the different process, let's say process A and process B can have different view for this single section. So let's say there is some object there. So let's say there is a rectangle object there, and you and I are viewing that object, but we can have the different perspective on that particular object. You can have your own view for that object, and I can have my own view for that object. So this is the same thing. There is a section, and the process can have their own corresponding view for that particular object. One can have the read and write memory page for that object. One process can view that section as the read and writable only, and one can view that section as read and executable only. So we will see this in a lab, and it will be a lot more clear. So in this technique, we are just going to create a section, and we are going to map the view of that section into the both processes, the local process, that is the injector process, the malicious process, and the target process where we want to inject our cell code. And there will be different page protection for both of these pages, but the section will be only one. So here are the steps to perform this injection. First, we will be creating a new section with a read, write, and executable page protection. And after that, we will be mapping a view of this section to the local process. So we are not going to map the section, but we are going to map the view of the section in the local process, and the view will have the read and write page protection. And we are going to do this with the API called anti-map view of section API. And after mapping the view of the section in the local process with the read and write protection, we are going to map a view to the target process as well. And this time we will be mapping the view for the target process as read and execute page protection. And this will be done by the anti-map view of section API as well. And after that, we are going to copy the payload into the view of the local process. So we are not going to toss the remote process here. We are just going to copy our payload into the local process view. And after that, we will just create a remote thread in a target process, and then we will execute the cell code from the target process. So we will understand this when we go into the lab. And to create the thread, we are going to use the create remote thread, create anti-create thread ex, or RTL create user thread. So let's just visualize this here. So first, the malware process will create a section, and the section will have read, write, and execute page protection. And we have the legitimate process and the malware process. And the legitimate process has currently it has one thread, and let's just assume that malware process has also one thread. Then we will map the view of this section in both process, and the view one for this malware process. So you can have multiple view of this section in a same process. You can have the view two for this section with the read and executable permission, but we are just going to map this view only once for this both process. And for the view that is mapped in the target process, the local process, the injector process will be read and write. So this will be C as the section as the read write. And we will be mapping the view of this section for this target process with the read and executable. That means we will be executing we have the permission to execute the code from this memory page. Then we are going to write the cell code using the mem copy. We are going to write the cell code in the local process view. This is the local process view that is mapped, and if we write the cell code here, it will be reflected in this in this view as well. So it will look like this. Now we have the cell code in a remote process. So we simply create a thread and we will execute the view. And we will simply create the thread and we have the new thread here. So these are all the APIs that can be used to map the section here. Now let's just jump into the lab and just quickly understand this technique. Now let's just go to the lab here and open up the lab for the section mapping. So let's put a breakpoint here. And we need a target process. So let's just open up the target process as the notepad. And in the system informer, let's just find the process ID is the 2960. And we need to set the process parameter here, 2960 here. And using the open process, so let's just execute this binary and we have put the breakpoint here. So we have passed the process ID 2960 and we can confirm this in a system informer. So we can simply open the process here and we have the handle to that process and we know what is going here. We have opened the handle to this remote process, that is the notepad. And after that, we are going to create a section here and let's just create a section and we are asking for the all write for this particular section, and the page protection for this section will be read, write, and execute, and the section type will be section commit here. And let's just create a section. And in the process hacker, if we just go to the section mapping, and if you look at the handle here, we can see the section handle here. It's a 4 KB and currently it's empty here, it's nothing here. Then we are going to map a view of this section in a local process, that is the local view address. So this is the handle to this section, that is we just created, and we are going to map this section in a current process, and we will be getting the address of the local view here. And the page protection, if you look at here, is the read and write, and there is the view on map flag here. That means we do not want the child process to inherit this section. So if we look at here the address, so let's just dump this here, is the 165A4C200. Now let's just open up the it's in the section. So here if we look at this address 165A4C200, so this is the page that we just allocated here in the section mapping. If you read it here, it's empty here because we have not written anything here. Now we will do the same thing for the target process as well. The parameters are same, only the address that is going to receive the address of the view will be different, and another one that is different is the current process. So instead of the current process, we are going to give the target process handle, and once we execute this, it will create a section in the target process in a notepad. And inside here, let's just look at the remote address view 18F532. 532, you can see the page we allocated has the read and executable permission now. If you look at here, it's empty now. And we have the three different tab here. This is the section itself, and this is the view that we mapped in this target process, and this is the view that is mapped in the section mapping, and it has the read and write permission. So what we do is we will just go and perform the mem copy there. Using the mem copy, we are going to copy the payload in the local view address, that is 165A4C2000. So let's just copy the cell code there in this region, that is 165A4C2000. So if I just reread here, you can see the cell code is already there. And if I reread the section as well, you will see the cell code is reflected here as well. And in the notepad, if I just do reread here, the cell code is also reflected here. Now we have everything for this cell code to execute, because we have the read and executable permission here. Now we can execute the cell code from the notepad.exe as well. So let's just go and create a new thread, and we will give the start routine as the remote view address. And currently, if you look at the notepad, we have only the notepad UI. Now let's just create a thread, and if you look at here, we have the message box popped up here. Now I hope you have understand this technique. So we have explained all these three techniques, and I hope you have understand all of this technique as well. So these are the references for this particular section, and so this is almost end of this webinar. So I want to hand over this presentation to the Yasser for the new offering.
Yeah, thank you, John. Just a second.
Thank you, sir.
Okay, so hope my screen is visible.
Yeah, it's visible, sir.
Okay, hi, yeah. Okay, so first of all, I would like to thank you all for being present in this, short webinar. And since we have a lot of different interesting techniques to cover, and the timing, was something that we were worried about previously, but we managed to cover at least three of the techniques that most of the red teams as well as threat actor used in order to escalate privileges and do a lot of stuff in the environment. So thank you, John, for the excellent presentation and giving us insights into the type of, the interesting techniques. So, couple of quick questions about this workshop. So the thing is that we will be uploading this particular presentation along with the codes that John showed in the VM, and it will be presented in our website. So there is a section in our website that is live tracks. So there you will find this event, and under this we will upload this particular video of the webinar as well as the presentation along with the codes and the slides. So it will be presented. It will be present there within 1 hour or so after this particular workshop. Now, let me just talk about our new offering, that is our attack and detect advanced process injection techniques. So here, you saw about only three techniques that we have showed to you, okay, about this stuff. Now, the thing is that previously the issue that we were facing, it was that the courses as well as the trainings that we built. So it was based on the previous assessments or the scenarios that we see currently in the organization. And it takes a lot of time to, compile the things, do the research and development of our content, and then, bundle all of them up in a kind of lab and offering and sell it on our platform. So it is actually, it takes a lot of time in order to build and package all of the things, because it's all in the R&D kind of things that we do when we prepare our courses, when we like build up our labs and sell it to our customers overseas all around the world. So the concept that we have come up with is offering from CyberWarFare Labs that we called as mini courses. So these mini courses are based on a specific topic that we majorly focus on, and that is heavily used by red teams as well as blue teams in the organization. So one of the example and how we are starting is with this particular mini course that we call it attack and detect advanced process injection techniques. So this is just a specific topic, and that's what we are referring to as a mini course, and this is what we have come up with. Generally, it takes us around 3 to 4 months in order to build a lab as well as content researched from scratch. So how about whatever things that we have, and it takes a lot of time, a kind of delay in our offerings. So how about let's say we come up with some kind of scenarios where we present this particular kind of mini courses as a offering to our customers. So that's what we have thought. Now like what we are planning, when what our vision is in this is that most of the topics that is covered during an assessment and that is heavily required by any of the individual, we will be covering those and we will be selling it on our website. So that is a very a very big offering that we have in very affordable prices. So it will be easy to grasp as well as focus on specific techniques, and it's very affordable and smooth practical learning plus example procedure. So that's what we will be focusing on, and we will be trying to add as much as we can in these short courses or mini courses that we are referring to. So there can be a lot of things. Now let's specifically talk about the first offering that we have, that is of this one. So in this particular workshop, John told us about the attack techniques, right? Now, for this specific course, how the blue team can understand all this stuff from a attacker mindset, we have compiled this thing as a mini course in this. So let's say whatever process injection technique that we are using during an assessment or during our R&D operations. So what all telemetries are generated, right? What all events are created? Also, how all these things are analyzed by the security vendors, that is heavily used by the organization. For example, various antiviruses, various EDRs, XDRs, or MDR, all the things. So how these security controls are analyzing and picking up and flagging and make the red team harder to execute their operations, as well as how blue team can become self-capable in understanding all these telemetries and gaining deeper visibility into the host machines or into the networks. So that is what this particular mini course is all about. There are a lot of techniques, a lot of ones that we have used or we have already executed it in the during our assessments or during our research. So we have compiled them, all of them in the format of red team. Now from the blue team, we have come up with a very interesting kind of lab that we call it in the ATP, that is we are utilizing Microsoft Defender for entity for endpoint for this particular task. Like we are analyzing the chains, how things are executing. Let's say if an attacker or if a red team performs any process injection technique, what all telemetry is generated. So we are analyzing this, going through each one of them, event IDs, so that on top of that, anyone, any organization or any SOC team can build the Yara rule on based on that and then utilize the things. So that is our vision on the base of blue team 2. So there are a lot of exercises, there are a lot of code snippets that you need, that we leave it to you to analyze. And the best thing is that you guys will be getting technical support in case anyone faces any issue during the whole exercise. And this is how the flow is divided for our certification procedure for this specific mini course, right? So generally, it is self-paced. It's all recorded. Everything is present in our platform. As soon as anyone enroll, they will get access to the content as well as the lab codes, as well as other exercises that we have prepared for you guys. So things are already bundled. It will be self-paced. The certification procedure is as displayed in my screen. So this is how the flow is. Also, the timeline is shortened to around 15-20 days, or let's say 1 month. So let's say if you are actually doing work anywhere, or you are like having some kind of operations running, so you can quickly go through these techniques and brush up your skills, and then implement the same in your local environment as well as in the operations that are currently in running, or penetration testing, internal penetration testing if you're doing in the environment, right? So this is the flow, and the main motive behind this mini course is to learn all the things in a short span of time. It's not like you are spending like 2 months, 3 months to only to understand a specific topic. We have compiled or come up with one-stop solution where anyone can cover all these things in, let's say, 15-20 days, 1 month, 2 months, as per your own schedule or as per your own convenience. You can study. It's all self-paced. Our technical support team is available 24/7 to understand your doubts, solve your doubts, and all the things. So it is there. So thank you all, for joining this webinar. We love to cover a lot of other techniques, but due to short span of time, we were not able to. But you will find all the details in our website. Regarding this webinar, it will be shortly uploaded, in this in our website, and we will continuously be organizing this kind of community engagement sessions, so that all of you will have an interesting idea of how things are originally happening in the market and what all things are actually required by the red team operators to upskill or to get into this particular domain, right? So our main vision is aligned with the things that we are currently offering. So if anyone have any queries regarding this workshop or anything, feel free to email us at this particular email ID, info@cyberwarfare.live. Also, those of you who have joined will also be getting an attendance certificate for this workshop. So we will be emailing you within 48 hours. You will get an email regarding the certificate in your inbox. If not, please check your spam once, and or whitelist our own domain, so that it directly lands in your promotions or the sorry, in the inbox folder. So things will be there. And those of you who are wondering, so it will be, if you visit our website, it will be available under this particular section, that is mini courses, and you will find all the details here. It's an addition of the red team as well as blue team in here, and we have you can find all the syllabus and all the things here, like what all things are present, all the techniques. You can see a lot of techniques, and the research that we have put in is already there. Now how you can detect all the techniques and understand the telemetry, so that you can better refine your defenses and place it and better project it in terms of policies in your own organization. So all the things are present here, and it's very affordable. So all the things you can see. Okay, you will be getting premium material along with HD videos for this specific mini course. There is no limitation on the examination. As soon as you enroll, anyone can attempt the examination as many times as they want. So that is the very good part that we are having, and all the requirements will be present in this. So as of now, it's only priced for around $49, and we have made it very affordable. So those of you who are looking forward to get a overview as well as deep dive and getting your hands dirty on these specific topic, like the one that we found is one of the most interesting and loved by the audience currently in security domain. So feel free to check it out and share the information on social media, tag us, share with your friends, share with your colleague, anyone you have. And if there are anything that we can help you in any case, in any regards, feel free, let us know. We are all ears, and looking forward to see you all next webinar. But whenever we schedule, we will let you know. Please follow us on social media, and thank you. Have a good day, have a great night, and have a good evening. So thank you all. Thank you all. If there are any questions, Jason is asking if there is any required knowledge in C programming. So a basic understanding how the code works is required, obviously, for obvious reasons, in order to understand about these topics, like in C program or C++. So yeah, a basic understanding is required, but not too much in detail. We will teach you about the APIs or the functions, as well as the the internal things that we are using. So feel free to explore these things and share it out on social media. Okay, so things will be there. And anyone have any doubts other than that, feel free to email us regarding this. And thank you all. You have been a great audience. Thanks.
So there is a question.
Yes.
Okay, so Sumit is asking about the if the course is available for lifetime or only for a period of time.
Yeah. Just to give you, Sumit, a bit, or sorry, a bit of clarity about this particular thing. Yes, the course will be available for lifetime, and we will be constantly adding new techniques in case we discover or any other researcher in the industry discover into this, and we will be adding it as an exercise on this. And what was the period of the examination? So see, like as anyone enroll in this, there is a kind of MCQ kind of question format that we are asking. So it will all be revolving around the techniques on based of red team and blue team that we have taught in this particular mini course. And yeah, the exam will only be MCQ based. Might be there are some questions that will be practical, but it will be a part of MCQ. So you need to, let's say, give answer in detail, or analyze the binaries, something like that, or do the process injection, something like that. So there are scenarios that might be there, but the format will be in the MCQ part. Yeah, practical, I can say that it will be a mix of both, not specific about any MCQ questions, but it will be a mix of practical as well as MCQ. If I talk in terms of practical, that's what I said, that we will give you a scenario, and then based on that you need to do that. So things will be there, and like this. Fahad is asking, will there be any more webinars? Yes, exactly, Fahad. That's what we are planning to. We are, trying to get as much as community engagement that we can do in our own platform, so that people understand about our, about our offerings, as well as the real world market experience that we have. So we are trying to, focus on that as well in this particular regards. Yeah, exactly, Sumit. So that's what we have in mind. We have a dedicated technical support team who is available 24/7 in order to answer your own questions regarding the offerings that you enroll in. Okay? So just be brief of whatever questions you ask. So our support team can, better understand it, and then share the things in details. So more information, if there are anything, feel free to let us know, and we will be organizing such kind of sessions, every weeks, or might be once in a couple of weeks. So that's what we have in mind. and feel free to let us know your thoughts and anything that we can do better to serve you all. Okay. Uh, so I think it's time, have fun, guys, and enjoy. Okay. And okay, so thank you all. Thank you all. Cheers. Yeah. Thank you, John. Thank you, Nandini. Thank you, Manisha. Thank you.
Thank you, sir, and thank you everyone for joining.